All right, so in the first video, we talked about things that were, or interest that was compounded at set amounts of time, so monthly, yearly, whatever it happens to be. But on this second part, there's a second type of compound interest formula, and that is compound it continuously. Compound it continuously. And that continuously is going to be important because it's basically the key word that tells you that you're using a different formula. The idea behind this is that when we're compounding this, it's not a set amount of time. So when we talk about compound it continuously, it's not compound it at set times or dates. In other words, it's not going to be monthly or daily or whatever it happens to be. Okay, it's not compounded in those set amount of times, but instead in very short quantities. But in such short quantities that it's not quantifiable. So there's not really a way to say, okay, it's compounded a bajillion times a year because it's not based on seconds or minutes or whatever. It's just continuously compounded. What that really means is it's compounded an infinite amount of times. It's compounded infinitely many times, okay? So in order to account for that infinite many times, we already had talked about using that, the number E before. That's what E is used for. It's talking about compounding continuously. It's really used mostly in financial problems. So the formula that you need to know whenever you see compound it continuously, the formula for continuously is A equals P E to the RT. So this is another formula that you have to memorize because it will not be given to you on a test or a quiz. So you need to memorize and know that formula. And you need to know that the only time you use it if it says that it's compounded continuously. The variables still mean the same thing. So A still means final. P still means principal or initial. All right, all of that's the same. R still stands for rate, making sure you make it a decimal. T still stands for time in years. The only new thing is this E. So you have to realize that the E is a number, not a variable. Just like pi is a number and not a variable. So we never substitute anything in the place of pi, so therefore we never substitute anything in the place of E. So we never substitute anything in the place of E. So let's do a couple sample problems here. So you deposited $1,500 into a savings account where your money will compound continuously. Again, as soon as I see continuously, I should be thinking A equals P E to the RT. At a 3% interest rate, how much money will you have after 5 years? So the only things I really care about in this formula is what's the A, what's the P, the E is just a number, what's the R, what's the T, right? So when I see deposited $1,500, that's not my ending amount, that's my initial amount, so that's my principal, so this is $1,500. 3% is my rate, remembering that we need to move the decimal over twice, so it's 0.03, and T is time in years, so this is going to be a 5. So then we need to go ahead and substitute in. So A equals 1,500, sorry, E to the R, which is 0.03, times T, which is 5. So then we're going to take out our calculator, clear it out. So P, so the 1,500. Remember that E is down here above the LN in blue, so I'm going to press the blue button and then that to get my E to pop up. to the power of 0.03. Oops, I actually have that power thing happening twice, so I need to delete this out, because I should only have one exponent there, not an exponent and another exponent on top of it. So parentheses 0.03 times 5, and that gives me $1742.75. Now again, this is money, so we went 2 after the decimal. The 1 makes the 5 stay the same, so that's as far as I need to go. But then I also need to write a sentence. So how much money will you have after 5 years? So after 5 years, and it's important that you put that, because if you don't, it could be a different amount of time would relate to a different amount of money. So after 5 years, you will have $1,742.75. Okay, so I'm encouraging you, why don't you try number 2 on your own? Pause the video, try it, and then you can fast forward through the video to see if you've got the right answer. And if not, then make sure you rewatch the explanation to figure out what you did wrong. All right, number 2, an amount of $1,500 is deposited in a bank account, paying an annual interest of 4.3%. Compound it continuously. So again, I see that continuously. I go straight to A equals P, e to the RT. Find the balance after 6 years. So what's my A? What's my P? My E is a number, so I don't need that. What's my R? What's my T? Well, a deposit is an initial amount, so that's $1,500 for P. So this is my P. 4.3% is a rate, but we have to move the decimal twice, so it's 0.043. T is in years in this case. It's already there, so it's 6 years, so we can go ahead and plug that in. So A equals 1,500 e to the 0.043 times 6, and then get out the calculator. 1,000 e 0.043 times 6, and that gives me 1941.51, because the 8 makes the 0 become a 1. And then I can go ahead and write my sentence. What is the balance after 6 years? So after 6 years, remember, it's very important that you write that, because if it were a different amount of time, this would be a different number. So after 6 years, the balance will be $1,941.51. Hopefully that was easy enough for you. Now we have a few problems that you're going to try on your own. Make sure you think about which formula to use. If it's compound it continuously, you can go ahead and use this A equals P e to the RT. If not, you need to go back and use the other formula that we had, the A equals P 1 plus R over N to the NT.